Okay, so let's talk about alternate quadrant representation. Like I said before, the choice of reference frame is pretty arbitrary. As long as you show what your reference frame is, it's fine. But you have to show it. If you don't show your reference frame, then it's a problem. Then we don't know what you're talking about. Okay, so just as you can say my mass is 50 because you didn't specify the units, you can't write a vector unless you show the reference frame. Okay, so let's say we have our x and y direction, right? And you have unit vectors pointing I hat, j hat, okay, along x and y direction respectively. And I want to write this force F5 Newton, which is making an angle theta from x-axis. I can write that easily, right? We saw that. So we have 5 cosine theta I hat plus 5 sine theta j hat, and that's great. But now I'm saying, you know what? I don't want you to write F in this reference frame. I want you to pick a different reference frame. Okay, and new reference frame is the one that's actually pointing along this vector. So x prime, or the unit vector along this direction, is pointing along the direction of the force itself, and then the perpendicular direction is this, j prime. Okay, so in this particular reference frame, how would you write the vector? Well, this vector is entirely pointing along I hat prime, which means that the force would be equal to nothing but phi, which is the length, times the direction, which is I prime. So if you pick that reference frame, there is no component along j prime direction, right? There's no component along j prime direction, and that's okay too. So if you show this reference frame and you write your vector like this, it's not a problem. Now the question is, what is the relationship between I prime and I? Are I prime and I same? No. Why are they not same? Because different directions, right? Is there anything common to them? What is common to I prime and I? Magnitude, right? By definition, unit vectors are unit magnitude, which means what is common to I prime and I is that they both have the same length, they have the same magnitude, but their directions are different, right? So I prime is not equal to I. It's a different vector. Okay, so where would this be useful? You will find that there are lots of problems where things have a particular or a preferred direction of movement, right? For example, if you take a block and you put it on an incline, right, then the block is only constrained to slide along this inclined direction. So if I was going to talk about the velocity of this block, I know that velocity would be along the incline, right? So does it make sense for me to draw x-axis this way and y-axis this way and then resolve this velocity vector v along horizontal and vertical direction? It doesn't. I would rather choose a reference frame where I can write this velocity vector much more easily. So if I pick my x prime direction to be this, along the incline, then the velocity would be nothing but whatever the magnitude is times a unit vector along x prime direction. So you'll often see that we will pick alternate quadrant frame representation, and as long as we are consistent, we are writing all the vector quantities in that reference frame, we are fine, right? You have to show the reference frame, and then you'll be okay. Now, that doesn't mean that you can't go from one frame to another. You can always go from one frame to another. Just as you can go from one unit system to another unit system, you can always go from one frame representation to another. Okay, so how do we do that? So let's say we have the same force of 5 Newton that's shown over here, and it's making an angle alpha from I hat and j hat direction. So I can definitely write this F in terms of I hat and j hat. It's not a problem. All I have to do is resolve this along this direction and this direction, and I'll be done. If I want to write this force F, let's say in I prime and j prime reference frame, I could do that too. All I have to do is find the angle this is making from I prime, and that'll be alpha minus theta, right? Alpha minus theta, and I can write that as well. Okay, so if you do that, you will get this equation, right? 5 times cosine alpha minus theta I prime plus 5 times sine alpha minus theta j prime. But if I said, give me the relationship between I prime and I and j prime and I and j. So essentially I'm saying, can you write the unit vectors in terms of the other unit vectors? That's essentially what I'm asking, right? This is a unit conversion, so-called unit conversion for the vectors. So if I have I prime, can I write it in terms of I and j? Sure, it's not difficult. This is just a vector. All I have to do is find the angle this is making from I, and I'll be done. So the angle it is making from I is nothing but theta. So I prime is nothing but cosine theta I plus sine theta j, right? And what's j prime? J prime is this. So what is this? What is the angle j prime is making from j? If this is theta, this is 90 minus theta, then this is theta, right? So this angle is theta. So this would be equal to 90 minus theta. And since this is 90, this is theta, right? So the angle that J prime is making with J is nothing but theta. So that means that if I resolve J prime, it will be cosine theta along J direction, and that's this component. And the other component will be pointing towards negative x, and that will be nothing but sine theta along negative I hat direction. So that's what we have. Okay? So this is the sort of stuff that should be clear to everybody. So if you don't understand this, now would be a good time to ask. Yes?
On a test, would we ever have to use alternate coordinate frames?
Absolutely, yeah. You may be given 2 coordinate frame, and you may have to go from one frame to another. But it's not difficult because you can always write unit vectors in terms of other unit vectors. And those of you who are playing with your phone right now, you will rue this missed opportunity because nobody will explain this to you again. Seriously. And you know who you are, and I know who you are. So I'm smiling, but actually I'm very angry inside. So when you're here, don't do that. Question? So this is theta, right? This is 90 degrees. So how much is this angle? This is 90 minus theta, right? And this angle is also 90 between I prime and J prime. So that is theta. Has to be theta, right? Because this angle is 90, right? So if I draw this separately, this is I prime, this is J prime, and this is the J direction. This is 90 minus theta, which we just saw, and this is 90, so this has to be theta, right? Yes? Okay. Any other questions about this? Now remember, let me tell you something. I have a lot of patience with one-on-one students. So you can ask me the same question 20 times, and I will not hesitate to answer it in the class, but not on Piazza. So if you ask me a question that I've already answered here or I've covered, I don't have a lot of patience. Your fellow classmates could answer the questions on Piazza, but the prerequisite for answering a question on Piazza is that you come to the class and you remain engaged and you're paying attention. And if you're not here, at least you're watching the echo or looking at the slides before you ask a question on Piazza. So if I'm not answering your question, or if I simply say, please look at the slides and read the echoes, that means that I have probably talked about this in the class. Okay, so like I said, I have a lot of patience for one-on-one students. So if you don't understand something, feel free to stop me and say, hey, I didn't understand that, professor. Can you please go over it again? And I will be happy to do that. Okay, are there any more questions now? Hey, I'm smiling. All right, okay, so this is not difficult stuff. So if you're paying attention, I'm pretty sure that you're getting it, okay?